Hi and welcome to my maths class. Today we're doing the theorem that states if a quad is a cyclic, then the angles are supplementary. Now this theorem is not in the proofs. We don't need to prove it, but it is necessary that you understand it in order to be able to use it. Now when we're using this theorem, then the reason we have is opposite angles of a cyclic quad. You can't just say cyclic, you can't just say it's a quad. You must say opposite angles of a cyclic quad. Now what are we talking about? A quad is a four-sided figure, like a quad bike has four wheels. If you look at this drawing, 1, 2, 3, 4. Now, more importantly, it is a cyclic quad. Now a cyclic quad is important because it means that all four sides touch the circle. A cyclic quad means all four sides must touch the circle. I can have a four-sided figure. 1, 2, 3, 4. But O is not touching the circle. So that can't be a cyclic quad. With a cyclic quad, all four sides must touch the circle. If it's not touching the circle, it's not a cyclic quad. Now it says that if a quad is a cyclic, so in other words the four-sided figure is inside the circle and touching the circle, then the angles are supplementary. Now supplementary means 180 degrees. So what they say is A plus D, angle A plus angle D, the opposite angles of a cyclic quad is equal to 180 degrees. Likewise, angle C plus B is equal to 180 degrees. Now, how do they come up with that? If I were to construct a line and another line, so what have I done? I've created an arc, and you know that the angle at the center is 2 times the angle at the circumference. So 2 of A is going to equal to a 1. And likewise, two of D is going to equal to O2. Angle at center is twice angle at circumference. That is one of the previous theorems that you have learned. Now look at what I'm showing you. When I am under, then I am also under the line. When I am on top of the line, then I'm also on top of the line. It can't be that the two angles, between the two angles there's no space. That won't work. So this one is not linked to this one. The red is linked to the red, the green is linked to the green. Now, if you look, O1 and O2 is equal to 360 degrees. Why? Because it's a revolution. So 2A plus 2D is equal to 360 degrees. It's like simultaneous equations. 2A is equal to O1, so I'm taking out O1 and I'm putting in 2A. 2D is equal to O2, I'm taking out O2, I'm putting in 2D. Then we're factorizing. I have A plus D. I took out a common 2, I'm left with A plus D is equal to 360 degrees. A plus D now equal to 180 degrees, which is exactly what they wanted. They asked us to prove that they are supplementary. Now remember, I haven't done this with given and construct and proof. I haven't done it like the standard theorems that we've done previously, because this one is not asked usually in an examination. But it is important that you know it, because if they do change, if they decided this one's easier, let's ask this one, then at least you know the concept. Thank you for watching.